Okay, so I had a recording for you, and I felt I did a fairly good job of explaining things. It was a fairly decent, short, and concise video, and my mic wasn't being captured, so I get to do this all over again, and in all likelihood, I'm not going to be able to say what I said in the previous video quite as elegantly. But still, I want to show you something. Now, before I get to that, I do want to update you on the reason why I haven't been uploading videos lately. This time I actually have a legitimate reason. I am working on the fourth part of the tutorial series videos. So that's underway. I really need to stop taking on ambitious projects and such because there's a lot of details that I'm putting into this video, and it's I'm not too terribly good at video editing, so it's taking its toll. But I will get it done. I just think, maybe after this video, for any future tutorials, I'm just going to tone it back a little bit, not stress myself too terribly much over how good a quality it is, because I really need to strike a balance between quality and frequency of uploads. That's the hard part. But yeah, still, I want to show you something here. So, little backstory: I've been doing some studying on internet networks and such, and how they work. And I've got the basic concepts, but I don't quite know the details. I'm basically back where I was with computers, where I got the concepts, but I don't quite know the details. So I decided, well, I used redstone to experiment with computers, and that worked pretty well. Why not use redstone to experiment with networks? In theory, it's a fairly straightforward idea. In practice, I can already tell it's not going to be that great, because the whole idea of the internet is basically just a network connecting a bunch of hosts, computers, if you will. And so building a couple different computers to act as hosts, that's no problem. The problem arises when you stop and realize that the entire network is also made of computers. So every switch, every hub, every router, every DNS server, every DHCP server, they're all computers. And so to build all of those computers, even for a small network, would put a tremendous amount of stress on my system. And it would just be horribly, horribly slow. So I figured, rather than going with computers, why not go with minecart networks? And I thought this would be kind of cool. I'm not sure how practical it would be, but I have seen people make minecart stations and rail networks in servers and such, and they're pretty fun. They've got some pretty cool designs out there. But the problem that I've always noticed is if you wanted to create a line between two rail stations, well, that's no problem. You create one line. But if you wanted to create lines between a whole plethora of stations, you have to create connections between every single station. Otherwise, you have to have a central station. And the central station works just fine too, but you still have to kind of manually connect the lines. You have to manually note which line is for which station and which line is for which destination and such. It works, but I think it would be kind of cool to have a rail network that was kind of self-sustaining, or sort of a smart rail system. Something that you could basically just hook a station up and it would figure out where you were. Yeah, so that's kind of the idea. And obviously, again, I don't know how practical this would be for a survival application, but for a cool factor, I thought it'd be pretty fun. So this is sort of my first baby steps into that direction, because one of the things that we need to overcome when it comes to creating a rail network is data transmission, because obviously we could just send a rail cart out onto a network and hope to God that it makes it to its destination, be sort of equivalent to UDP, data transmission protocol. But obviously we want to, we don't want to just send out and hope for the best, because if this were to be practical, you would most likely be using this not only for player transportation but item transportation. If you're sitting here hauling a minecart chest full of diamonds across a world, you don't want that to get lost. So the whole point of this is, or the whole name of the game is intelligence. So we'd want the network to know where things are coming from and where they're going. And so in order to do that, we basically have to transmit data between points on the network, routers, if you will, nodes, hosts, whatever. We have to be able to transmit data between two nodes and have one tell the other that the packet that it's sending is going to this destination. So obviously sending an actual packet, that's fairly straightforward, or sending the package, I should say, is fairly straightforward. You basically just put whatever you want into a minecart and send it off. It's the information that's the difficult part, because we can obviously send it over redstone signals. That's probably going to be difficult to keep synchronized. Option B is to do sort of a 2 minecart system, where the first minecart is a minecart chest with your routing information in it, and the second minecart is your payload, be it a player, items, an entity of some kind, doesn't really matter. Could be a book. You could have a minecart with a book in it, and that could be like a mail, minecart. You could totally have a mail port and have a mail protocol. That would be kind of cool, actually. Maybe this might be a little bit more applicable than I first thought it would be. But I'm getting ahead of myself. Point is, we still need to actually tell the nodes in the network where this package is supposed to go, and that's going to require information. So I think the best way to do that is with a 2 minecart system, where you have one minecart with the information and the other with the actual package. And so that brings me to the first challenge that I wanted to overcome, was how do you get information over a rail network? Because obviously we have ways of transmitting items, but data is a little bit more tricky. I don't think anybody's ever done that before. So this is my first attempt at doing that. Now, this is obviously just for receiving the data. I still don't have any way of actually transmitting the data. But the idea is that once I create something like that, I could create 2 of these, put them together, and get them to talk. So I'll demonstrate how this works in just a sec. It's actually fairly straightforward. All of this stuff is basically just peripherals to make it work. It's primarily this part right here that does all the work. But before I get into that, I do want to mention some minecart transmission protocols that I want to establish. So obviously the actual payload is what's going to be traversing through the network. And you would think that this would kind of travel with it. It's probably not going to happen. And there's a very good reason why. Basically, minecarts with chests, they don't stack in droppers and stuff. So we can't just destroy it, store it, and then send it out somewhere. We'll have to use minecart PEZ dispensers, going super old school with this. But with the minecart PEZ dispenser, we have a very limited quantity of minecarts that we can store. So that means that anytime a node sends out a minecart, we need to make sure that it gets sent back. Otherwise, there's no knowing that that node will ever get its minecart back. We basically need to make sure that all nodes get back what they send out, so that they never run out of minecarts. So the idea with this system is data can be extracted from the minecart and interpreted and turned into a byte. In this case, it's a byte, but eventually I want to try and go for 3 bytes. And then once the data is extracted and interpreted, it can be sent back into the minecart with the order preserved. Now, I have tested this off camera, and it does preserve the order, but for whatever reason, recording it seems to scramble it. We'll get to that in just a sec. But then once the data is sent back into the cart and the order is preserved, we can then send the minecart back to the sending node, and that node would get its minecart and its data information back. And then, of course, this would then take that information, process it, and figure out where to send the actual payload, which it would then send the payload over to the appropriate port, assemble a new package header with new information, and send that out. So it'd basically be, these would be hopping information, basically. So you can imagine this as sort of like your MAC address information, although that's really simplifying it, like majorly. But these would basically dictate hops. This would be what actually traverses the network. Yeah, so how this actually works is fairly straightforward. So first things first, how are we encoding information? That was actually a bit of a trick. Originally what I wanted to do was I wanted to use colored wool. And the reason why is because bit density. There are 16 colors, which means you can, for every block, store 4 bits. The problem is that these things are stackable. And so if I were to send 2 yellow wool into a minecart with a chest, it should be yellow yellow in the slots, but there's what's to stop them from stacking into just 2 yellow. So, and the same thing goes if I were to go like yellow, pink, yellow. What's to stop this last yellow from just stacking with a first? So there's no real way of preserving the information with that. So I had to go with non-stackable items. And so in this case, I chose water bottles and shovels. Now the shovels, they don't matter, but the water bottles do. And the reason why is because I'm using a potion brewing stand to actually sort out the different non-stackable items, because you can't just throw them into. This was the other challenge, is using non-stackable items. You can't use hopper filters because those require items to stack. So we had to use a non-stackable item sorter. And so in this case, I could have gone for water buckets. I decided to go for water bottles, and the reason why is because they can quickly be separated into one of 2 categories, either water bottles or not water bottles. And so that's basically what we've got our data encoded as, is water bottles or not water bottles. Now this wooden shovel can pretty much be anything. It just has to be non-stackable. I just went for wooden shovels because it was there. But yeah, so that's the data encryption. And then to actually get the data out, like I said, this is the circuit that does it, and it's fairly straightforward. We basically have 2 lines here. We have phi1 and phi2. Don't let the names scare you. They're basically just 2 lines that are on that will momentarily turn off at different phases. And those phases are controlled by the clock. So when the clock goes high, this side is a rising edge detector, which means it's going to pulse low and then high again on the rising edge. This side is a falling edge detector, so on the falling edge it'll pulse low then high. So basically these 2 lines are going to go low high, low high, low high, low high, and over and over and over again. So following this through, we'll make a basic assumption. First, we'll assume that there's already an item in the hopper there. We'll also assume that there's already items in these hoppers. Okay, and sorry, I should specify. There's an item in one of these hoppers. There's never going to be an item in both of these hoppers at the same time. We'll get to why that is in just a sec. So on phi1, that's going to go low and it's going to go high again. A new item is going to be pulled from the hopper, from the minecart, and it's going to move into the hopper. And the item that was in the hopper is going to move into the dropper. Now, that's on the falling edge. On the rising edge of phi1, it's going to stop that, of course, but then it's also going to dispense the dropper. So if there's a water bottle in here, it's going to move into the brewing stand. If there's not a water bottle in here, if there's something else, it's going to stay put. Then, when phi2 comes around, and it goes low and high again, the items that are currently in one of these 2 hoppers is going to move down to the chest, and the items that are up here, either in the dropper or in the brewing stand, is going to move down into the hopper. So, if it's a water bottle, this line is going to turn on. If it's not a water bottle, this line is going to turn on. And so these are complementary. If there's a valid bit going through there and it's a 1, it's going to be this line. If it's a 0, it's going to be this line. But if they're both off, that is what is referred to as an invalid bit. And I'll get to why I chose to do it that way here in just a sec. Following it through, the items collect in that chest down there. They then follow the hopper line through here, dropper elevator up here, and they're stored in the chest up here, presumably in the same order. Now again, I was having some issues getting it to remain in the same order whilst recording, but when not recording it seems to preserve its order just fine. You'll just have to take my word for it. But that basically stores it here so that when the process is done, this hopper can be enabled and items can flow back into the minecart chest and it can be sent back. Anyway, as for the data, if this is on, it's a 1. If this is on, it's a 0. If neither are on, it's invalid. And the reason why I did it that way is because there's going to be an extra clock cycle at the beginning to actually get the data started, just to get data into here. And there's also going to be an extra clock cycle at the end to get the data that's in here out. So there's going to be 2 extra clock cycles that will produce invalid bits. And we don't want those being recorded. So even though this line will be on, it's not actually a 0. So the way I solve that is this is just being fed straight into a shift register. So the shift register is just going to hold whatever's on the output, and it's latched by phi1. So every time phi1 goes low and then high, it's latching the shift register, but that can be disabled by this torch. Now, that disable is controlled by this line, which is connected to both the high and low output. So if it's high, it's going to enable the clock. If it's low, it's also going to enable the clock. But if neither one of these is true, if it's an invalid bit, the clock is disabled. And so that basically just prevents invalid bits from getting through into the shift register. And that's fairly easy to do. Now you can see there's already some data on here. For the most part, it matches. The only problem is, and I'm not 100% sure if this is the case, but this does sit on a chunk border, so it seems like these are kind of getting messed up because of that. I don't know if that's necessarily the case, but if you actually watch the data as it comes out, it does match. It does work. It's just these last 4 bits get buggered up. So yeah, that's nothing much I can do about that except move it, but I'm too lazy to do that. So enough rambling. I guess I'll show you how this works. So here's my bit order. We have, let's see, I believe that's going to be the very first bit that's processed. So it's going to be 10110010, and that's basically the order that's going to come out is 10110010. So if I go ahead and start this now, when this is completed, if this is completed, I don't know. The idea is that when the minecart comes in, it would automatically trip this so that the clock would start. Now the clock starts, it starts pulling data out, and you can actually see the stuff going crazy down there. And then once we've got the invalid bit, that's basically the end of it, that would signal the clock to shut off. So you can see we've got the data back on there. If you're actually watching the shift register, you can go back and watch it again. But the data was coming out correctly. It's just down here it got messed up. So that does work, fortunately. Now, as far as the clock is concerned, this is as fast as I can get it to go. I've tried going faster, but it messes up the data if I do that. Let's see what else. And then once the clock is stopped, the idea then would be, you can see it's gotten messed up. I got the same result last time I was recording too. But once the data is stored back into the return chest, the idea is that this would go low, enabling the hopper, sending the data back in, and then we'd send the minecart back. So that's kind of the idea. Obviously, I've still got a long ways to go. I may have to slow down the clock a little bit to get it to stabilize during recording, but I don't think that's really too terribly big of an issue. And yeah, this was basically just, I wanted to get a video out for you fairly shortly because like I said, it's been a while since I've recorded. Obviously, I still have the Fat Stacks project, and I've also got the video, or the computer tutorial video that I'm working on. So those have kind of been taking up my time, and I haven't really been able to upload anything recently as a result, but I just wanted to get this out here because I wanted to show you this, and this, like I said, was an idea that I had on my mind for quite some time, and I figured it'd be super cool to show you. So hopefully you enjoyed, and hopefully here soon I'll get the last tutorial video out for you. And that'll be that. Obviously, this isn't going to be a big project right now. I don't like working on too many projects at the same time. So I'm going to finish up the tutorial videos and maybe Fat Stacks first before I turn this into a full-fledged project. But in the meantime, this will be on the back burner. So yeah, hopefully you enjoyed. Thanks for watching.